I'm LeMasters. I've been doing incident response for about 5 years. Some malware analysis, reverse engineering type work. So the rest of my bio is on the website if you want to check it out there. Just two quick admin notes. We're kind of short on time, so we're going to blow through these slides, and if you would hold all your questions to the end, we'd appreciate that. A quick note on the tool. So we have a tool code word that goes along with this presentation, but it's still pending approval, so we're not going to be able to release it here at the talk. But I mean, we're optimistic in a couple of weeks, we'll probably get that resolved and be able to release it so everybody can check it out. So can't really comment any further on that, but if anybody's interested, you can come up after the talk and we can chat some. So I guess I'll hand it over to Mike. He's going to kind of introduce the methodology to you, and then I'll cover the tool later on in the talk.
All right. Good morning, everybody. Welcome to our retry methodology talk here at Black Hat. As Aaron said, we both have lots of background in incident response and the various pieces that go along with that. And we came up with this idea based on some problems that we've seen in the past as we've tried to do incident response on a very large scale. So, as Aaron said, we're going to probably just try to jump right in and go through it. Try to hold all your questions to the end, and then we'll address what we have time for then. So, what is retry? This is it's a new approach to incident response that we came up with based on lots and lots of experience in finding that the current methodologies out there just fail to address all the issues that present themselves during these emergency situations. And there's 4 really distinct phases, so it really lends itself well to planning it out and knowing where you are in the process. And ultimately, we believe it's going to save money. And I mean, obviously, that's a huge thing whenever you're talking about doing incident response, is it can be very, very costly. So we think if you plan ahead and use this methodology, it has the potential to save lots and lots of money. So the talk is broken up into 2 different sort of halves. The first half I'll be talking about the first 3 stages of retry. And the second half of this talk is the 4th stage, which is the traditional incident response piece, and that's where Aaron's going to talk about the tool that he's written. So to get started, there's some important, assumptions that we make that we want to make you guys aware of. For this methodology to work, it really lends itself well to very large and very complicated networks. If you've got a really small network, this is really way overkill. This is, thousands of machines with just totally crazy architecture and infrastructure that makes it very complicated. The idea is that this is a full compromise of the enterprise. It's not just a few machines with config or what have you. This is really tons of computers that are infected, and then possibly tons of other ones that you haven't found yet. And so that's the main piece of the background. Also, the last bullet there is forensics. While important in any investigation, we're not going to focus on that at all. This is really response and getting your network back up and running. So we're going to kind of ignore the aspects of forensics. So the current options that we've come across, there's basically 2 different schools of thought on how you do large-scale response. Option number 1 is you shut down the network and rebuild it. There's some real problems with this because your people essentially end up being cut off from being able to do their job, and that becomes very costly. The good news is you do have the full 100% assurance that your network is clean when you get done. The second option is you rebuild online, and this is the option that most people end up taking, right? This is where you identify hosts one by one, whether it's network-based or host-based signatures or what have you. Identify a host and clean it up as you find them. Obviously, the upside of that is your users continue to operate, they continue to work. The bad news is so does the bad guy, right? He's on your network, and as long as he's got a backdoor that you haven't found yet, then you've got data that potentially is flying out the door. So that's these are the two things that we really wanted to address, the cons of both of these things. So we came up with Retry, and the idea is you got to find a way to enable your people to continue to work on your network while cutting off access to the bad guy and ensuring that your valuable company data doesn't get exfiltrated and stolen and used by somebody else. We threw on here that there is sort of a con that it can be costly, but it's really an upfront cost, which is why we threw it on here. This is going to save you some money down the road, but it's always hard to convince management that you want to spend money up front to fix a problem that doesn't necessarily exist yet. So we want to throw that out there, that there's a lot of work that goes into setting this up, and there's some resources that you need to spend up front, but you really are going to reap the benefits of it down the road. So we have a couple case studies. The first case study, the report where we got all this data from is down there at the bottom if you're interested, but there's 2 surveys done back in 2006 and 2008, and we wanted to get some cost figures together. So back in 2006, when the average cost that an enterprise would spend on cleaning up is about $4.7 million to clean up an average wide-scale compromise. And a lot of this was based on a per-record cost, right? So if you have a database and you have to go notify your users and buy free credit report for a year for these guys, so there's a lot of cost in that, and then a lot of cost in obviously the cleanup and lost business. 2008, same survey, the cost had gone up to $6.6 million, with the most expensive cleanup effort that year about $32 million. So it's very expensive, right, to do these types of cleanups. One of the things that the report pointed out, and something that we've experienced ourselves, is that the cost of the actual cleanup is relatively inexpensive compared to employee downtime, right? No matter how you do the response, whether it's one-off and you're finding things, or if you're doing it, cut off the whole network, employee downtime is going to occur, and it's going to cost you a lot of money. So we wanted, that was one of the primary drivers that we wanted to address. Also, first time, one of the bullets I thought was interesting is first time compromises cost a lot more. So I guess if you get broken into a lot, you get a lot better at it, and I guess there's a silver lining there. So this second case study is what it would cost if you were to take down an entire network and rebuild it from scratch. So this is a case that actually Aaron and I both worked on back in 2007. Approximate total cost of $7 million to take down a whole network for up to about 3 weeks and rebuild it from scratch. Only $2.5 million of that was the actual incident response piece, the IT staff, the time involved, and the tools. The $4.5 million was employee downtime, right? So based on this, we were like, there's got to be a better way to do this, but nobody had really come up with any good solutions. So we came up with our solution of Retry, and we actually had an incident where we kind of designed this around and put together some cost figures that we submitted to the group that had the problem. We estimate that for a network size of about 10,000 users, you can do the entire cleanup for approximately $3 million. And there's a cost breakdown, in the middle of the slide there. Essentially, the most expensive piece of this is going to be some of your software licenses that you're going to have to acquire if you don't already have them. And that's for some sort of an application streaming thing like a Citrix or a similar vendor. Now the good news about this is for about $3 million, you get to rebuild your entire network while not taking your users down. So it's essentially a little bit cheaper than the other 2 methodologies out there, and you don't have any impact on your organization. So this is what Retry is. There's 4 stages or 4 phases to Retry. The first phase is preparation. This is where you integrate it into your COOP plan, and we'll talk about some of the aspects that you want to keep in mind when doing so. Really, obviously, the time frame doesn't matter. This is all just prep work. Phase 2 is your sort of damage assessment. This is when you realize you have a problem. Your signature's gone off somewhere in the network, either host or network-based, and you've got to decide, what your response is going to be. Hopefully, you can gather enough data to figure out, scope and all that within a couple of, 24 hours or less. And then phase 3 is really where the meat of the methodology comes in. It's where you do some network segmentation, and then you bring your users back online. Now, there is a little bit of user downtime, a few days. We think with lots of really good planning that can be very minimal, only a few days. And then phase 4 is the traditional, incident response piece where you're doing the full-scale investigation and you're recovering and you're restoring images and whatnot. So phase 1, getting thirsty. Phase 1, the prep phase. So when we started to look at this, we realized that your traditional COOP model needs to be slightly modified for this to work well. One of the issues there is under a traditional COOP scenario, a lot of times you're preparing for a natural disaster of some sort, right? A hurricane or a tornado or a plane hitting a building, so you've got a hot site or another site where your users are going to go to and work from. In this scenario, you don't have that problem, right? That really you just have to worry about the cyber aspects of what's going on. So the whole idea, most COOP plans already have physical backups that are offline, but there's other aspects that we're about to talk about that you want to keep in mind for a cyber type COOP scenario. So the first piece is, the people and resources that you need. For cyber COOP, you really just need a bunch of IT folks, right? The idea here is you got to identify your strongest guys, whether on the network side, on the server side, on your desktop side, and put them into some sort of tiger team for this. Hardware, you're going to need, you're going to be standing up a redundant set of servers for a short period of time. So you either need to procure some extra hardware or go out and repurpose some stuff that maybe isn't being fully utilized. Keeping in mind this is an emergency, so it's probably something that you can do is just take some extra servers offline. And then the software piece, which I mentioned earlier, this is sort of the thing that really enables you to do a lot of this, is having some sort of a software out there that allows you to host your applications out in a different network and streaming back the interface, essentially like a Citrix style interface back to your users. We talked to some of the vendors. These are just, these are prices on their site. Obviously you can negotiate. Some of them are open to renting the software in an emergency situation. And the last piece is obviously the incident response tools, which the tool that Aaron's written really helps to address. So one of the things that you don't have to worry about under a normal COOP scenario, but you would in this, is that you're still operating the same exact network that you already have. So putting together, prepping some scripts and SMS packages or whatever software solution you may have, doing it ahead of time and not doing it when you're in the middle of an emergency will really help. The bullets here, we'll get into why all these are there, but this is just some stuff to, if you go back and look at the slides later, that we would recommend for putting into your plan. Obviously, your users are going to experience sort of this, in this scenario, they're going to have a new way of doing business for a little while. So putting together some user notifications and training packages up front save you a lot of time when you're in the middle of an emergency. And then this is just, it should be pretty obvious, but anytime you can leverage, some sort of virtual infrastructure makes restoring these images a lot faster. So, VMware or something similar, very helpful in this type of a scenario where you're pulling images back off of tape and just powering them on. And then the last piece is something that people often forget. You can leverage a lot of your current tools that you already use for just, network maintenance can be used for incident response. So don't forget about your tools like SMS and other tools that you can use to deploy software. And then the last aspect of of the preparation piece, and this is probably the one that's most important, is to know your network. You wouldn't believe how often Aaron and I have done some sort of response where you show up and they don't have a diagram, they don't know what is there, they don't know what trust relationships they may have, they don't know where all their connectivity points are. I mean, this is just basic stuff that you really have to do. It's not a lot of fun, but it's got to be done. And then the last bullet, asset inventory, is huge, because how do you know you're done if you don't know how many machines you have? So having a pretty decent count of your network and knowing where everything is really important. So phase 2, this is the damage assessment part. This is the traditional incident response where you figure out how bad your problem is. So you're going to perform the basic steps, right? You want to figure out the attack vector. You know, how did the bad guy get in? You're going to identify when it happened, which is critical for knowing what backups are good, what backups are not good. Try to quickly identify some sort of a command and control channel. You can cut that off. Obviously that's beneficial to find that as soon as possible. And then also start submitting samples of any malware that you found to your antivirus vendors so that they can begin to put together some signatures that you can leverage. And then obviously the last big bullet there, determining the scope, is huge, because until you know the scope, you don't know the most appropriate way to respond. So if it's one host, this is way overkill. But if it's 500, 600 hosts on your network, this can really lend itself to your situation. So the two big things that we talked about when we were coming up with this was, what are the two questions that you need to ask whenever you're trying to decide if retry is a good fit? One is obviously, do you have all the backups and stuff that you need to implement retry, right? Are the resources available? If they're not, move on to plan B. And then the second piece is, does the evidence support this, right? Is the scope of the intrusion big enough? Does your network warrant this drastic measure? If not, then feel free to use the other two traditional methods. And then the last piece is, obviously you're going to have to convince your boss and your management that this is the way to go. So build your business case and quickly try to get him to sign off on doing some crazy things on your network. So we'll assume that the boss has approved and gone forward and the situation did warrant doing this. The first step is cut off all network access externally, right? So you basically are just cutting off any access to the internet. The whole point here is to stop the data exfiltration that is potentially happening all the time. Second and third piece obviously is talk to your users, get the word out. If you cut off network access at the outermost point, your email still flows internally, so you can still get messages out to people and you can still communicate. So use those things that are still in place, and then immediately start calling in all your geeks and get them working on building the retry. All right. Phase 3. This is where it starts to get exciting. This is really the meat of the talk. So if you guys were sleeping, wake up now. This is the cool stuff. So we're going to start with some just real basic fundamentals of how we're able to do all this. One, we're leveraging VRFs, or virtual routing and forwarding. Cool technology that essentially allows you to have multiple copies of a routing table on the same router at the same time. The big piece here is that you can have the same IP in multiple places on your network, which is critical for what we're doing, right? So everything gets a tag essentially based on the VRF that it's in. So you can have the same IP in two different VRFs, and everything routes just fine because it's tagged appropriately. Depending upon the size of your network, MPLS really extends that and makes it enterprise. And so, we threw that in there. Essentially, we're talking about very large networks, so MPLS would probably be the way to go, making this scale well. So to really summarize how this ends up working and to go into sort of a scenario, what happens right now, you probably have networks set up where you got different VLANs set up for, maybe accounting and, your marketing and different groups. The idea is to take VLANs and map them to the VRFs. So you can essentially take all your current VLANs, and put them into one big VRF, which we'll call the quarantine network in a second. Now, the cool thing about this is you can take, through VLAN technology, you can obviously manage down to the switch port. So you can essentially have a laptop or a desktop sitting on one switch port, and the printer that's network enabled sitting on the next port over, and be on two totally separate networks because of this technology. And that's essentially what we're going to end up doing. So you're going to end up creating two logically separate networks. The first network being the quarantine network, or the QNet. This is, like I said, using that whole VLAN and VRF technology. Basically, you take everything that is your current enterprise and throw it into this one, QNet bucket, so that all packets that are being routed through your network are getting tagged and set for the QNet. Now, the important thing about the QNet is it has no external connectivity whatsoever, right? So that's really important. The idea is that you don't want the bad guy, whoever is running your network alongside of you, to have any access in. Simultaneously, you're going to create what we're calling the clean network, for really lack of a better term. It's a mirror copy of your current network from IP and routing perspective, but this network has all the regular connectivity that you would have. And initially, this one's going to be totally empty. So for those of you who are more visually inclined, this is my really terrible Visio diagram. On the right-hand side, you see the QNet. It's all by itself. It's logically separate, even though it's in theory running on all the same hardware that the CleanNet is. And the new CleanNet is sitting off to its own side. There again, completely by itself. All the packets are being appropriately tagged and whatnot. And there's going to be a firewall in between that essentially allows very limited traffic between the two networks. Now, as you can see, the CleanNet has regular internet connectivity on out, right? The only way for the QNet to get out is to go through the CleanNet, and that's really important. So to talk about the networks a little bit more, like I said, the QNet, everything that you currently have goes there. Keep in mind, you got to keep this network operating, so all your servers, all your basic infrastructure is there. All your instant response and security tools are going to, you're going to keep them there and throw them into this network. The CleanNet is kind of the more exciting aspect. This is the new network that you've created where you're going to start restoring images of your servers prior to compromise. And the cool thing is because it's a mirror copy of your other network, all your current firewall rule sets and IDS signatures and DNS records will essentially work because you're going to restore a copy of your mail server to the same IP it once had inside the CleanNet. So you're bringing back all your basic infrastructure. We recommend, based on what happened on your network, bringing the printers over. Obviously, printers can be compromised, so keep that in mind. But if you don't feel like they were targeted in the attack, then bring them over and put them on the CleanNet. And like I said, that's where the whole printer can be on your desk sitting on the CleanNet, workstation sitting in the QNet. So this network, like I said, has standard connectivity. All the firewall rule sets that you've spent years building all work. And the one big piece is this ASI cluster. This is that Citrix or other solution that you may have that you're virtualizing all of your applications inside the CleanNet. So you've got two networks set up. You've got basic infrastructure in both networks. One's completely cut off. One's completely just normal and talking to the internet as it normally would. So you got to basically glue the two networks together and make them work. And the idea is that you can allow the QNet to talk to the ASI cluster, which sits in the clean network, only over the right ports and over the right protocols. The main idea here is not that there's anything special about this, but that whatever backdoor or virus that's running around your network essentially can't speak that protocol and doesn't have a way to communicate through the cluster, the application cluster, back out to the internet. So in most scenarios, you would allow just HTTPS traffic through. It would be encrypted, and all logons should be some sort of two-factor authentication, so that it's really just best practice. And then for the DNS aspects of getting your people there, obviously there's two basic options. One, you could point everything there, just black hole the entire internet to your cluster, so that anytime a user opens up a browser, they essentially get the the CleanNet's cluster that you want them to go to. Option number two is that you set their home page to some record that you created and point that one there. Now the added benefit of that option too is that you can then essentially black hole everything else to another server, some sort of a tar pit server, where you can start to analyze the traffic. Because in theory, over the next few days, as your users get used to using the CleanNet option, any other traffic that you would see could lead you to other infections. All right, so the cluster that you've built, we're recommending that you put just basic Office applications on it. The idea is you're sitting here in the middle of an emergency. We're not trying to offer the entire world to the users, just the basics. So email, your Office application suite, the web some way, whether it's IE or Firefox or what have you. And then any other really unique custom applications that your entire business needs to operate on. Something that wouldn't be there, obviously, anything that's media rich, multimedia rich, doesn't stream well. I don't care what they tell you, that really doesn't. And then any locally installed applications obviously aren't going to be there. So unless you know about them and they're enterprise-wide, they're just not going to be there. Now, they may still be on the user's computers, but if they require any access out, obviously not going to work. So just something to keep in mind. To secure the cluster, we came up with this list of things that you'd want to configure. Obviously, no copy and paste between the two networks. It's a little painful, but users will get used to it. Essentially, they're not going to be creating anything on their local machine, so it really doesn't matter. Obviously, no device mapping. You don't want hard drives and other crap being mapped back into the QNet. You want to keep everything that they access on this cluster out in the CleanNet. Locking down all the applications, just the basic stuff, using dep where possible. Essentially what you're doing is you're locking down this environment as much as you can, and you're turning all the client machines into dumb terminals that are going to be hitting this thing. So you've effectively turned your QNet, or your old enterprise as of a few days ago, into a huge network of dumb terminals. So we thought we had a great idea, and then we realized, crap, we got the file server to move. So how do you move a multi-terabyte server full of files that you have no idea what's on there? Well, very carefully. You're going to obviously have some sort of offline backup of it. So restore the backup from prior to the intrusion. And then you have several weeks or months worth of data that you've had to deal with that was either created or modified since then. So obviously, throw any antivirus tools that you've got at it, scan it with any instant response tools you may have for known bad hashes, and then make use of the Moist and other applications out there from Microsoft or other places that might do some sort of validation on the files. Disable JavaScript if you can inside of Adobe Acrobat. And then the obvious last piece is you're not probably going to bring over any user executables that are found. You can put them to the side and look at them later, but you want to be really careful what you're moving over, because you go into a lot of trouble to build this out. You don't want to reinfect yourself. So for those of you who aren't familiar with the technologies I just talked about, just a quick thing on Moist, the Microsoft Office isolation conversion environment. Pretty cool. It basically takes Office 2003 and previous versions, which are binary file formats, and converts them to the XML format of 2007. It's done with really special permissions and whatnot, so that any sort of exploit code that's in there will cause it to crash without actually owning your box. So you can essentially enforce that on every 2003 and previous file. So you can, anytime somebody opens a file, you can basically enforce it to do the conversion for you. Dep, data data execute prevention. Basically just trying to make areas of memory that aren't executable stay that way. So turn that on. How many of you guys run Adobe Acrobat? There's more of you than that, but okay. So, that's pretty much, in my opinion, at this point, the biggest backdoor on everybody's network. What is it? Every 3 or 4 weeks, there's a new O day in there. So, sorry, how many of your, when I said you guys, I meant your networks, but yes, how many of your users run it? So, everybody's users run Adobe Acrobat for the most part. I'm not the first person to say, it may be worth looking at other products at this point. At least in the middle of some big intrusion that you're dealing with, right? Not that the other products don't have problems, but nobody's attacking them. Restoring user services, all the basic stuff, enforce two-factor authentication, make sure that, service accounts get their passwords changed because you're going to be restoring AD from previous states or everything. All the accounts that they could have already exfiltrated passwords from are going to be in the new CleanNet. If you haven't planned it out, the client that you need to access the cluster may not be installed. You could always add that to your build if you're doing this as part of your COOP, so it may already be there, but install it. One of the cool things that we thought about was removing all the applications from the user's desktops, right? Using some sort of SMS or something. Essentially, you don't want them creating content in the quarantine network zone because you don't want to address having to move that data later. So you want to force them to use everything through the cluster. And then the last piece, obviously, start doing the training that you built. All right, so that pretty much wraps up phase 3. Once you've built that all out and you've got your users back up and working through some sort of an application streaming platform thing in the CleanNet, now it's on to phase 4, which is where you do all the really cool, instant response pieces and, look for the malware and find it. So, this is where the basic stuff just kicks in, right? You're going to go out, look network signatures, hopefully that you may have gotten some new AV signatures. Figure out, do you have any regulatory issues that you've got to deal with, HIPAA, SOX, PII, what have you. And really this is where I turn things over to Aaron and let him talk about his really cool tool that we built for this.
All right, so like Mike said, we're kind of in phase 4 here. You're doing your traditional incident response. You think you've isolated the infection, established a perimeter. Now it's time to move in with your forensics tools or your security tools to kind of do some cleanup, do some root cause analysis, things like that. So these are your basically your options are commercial forensics tools, which anybody has done incident response is familiar with the main products that I'm referring to. They're very costly, they're complicated, not the best user interfaces in the world. Very steep learning curve. There's certifications wrapped around these products. Expensive full-time resources. So you gotta have a guy that's your in-case guy or your access data guy that knows the tool and can respond quickly. They're also very forensic, focused on forensics. They have everything in the tools. They have a forensics wrapper around them. So that's an important consideration for somebody like law enforcement. But for a network defender, that may not be a top concern. Maybe the top concern for you is to get information quickly, so you can determine where the threat is and isolate it. A lot of the commercial tools are painfully thorough, so it takes a long time to perform some of the analysis. And your second option are your enterprise tools, some which Mike talked about, like compliance scanners, like Retina and those types, AV scanners, enterprise antivirus, and any host level security you may have, like a HIPS product. Problem with these is that most of the time they're poorly configured. You don't have the right settings, or the heuristics are tuned down too low and they don't alert, or they do alert and they're not watched, or they come there and people don't report on them, that type of stuff. So, and also the coverage has been, at least from what we've seen, coverage is traditionally pretty poor. So you may have a 40% coverage of antivirus on all the hosts on your network. And on top of that, these other problems, like they're not watched and things like that. So these tools are very problematic. And then you have your open source tools, which are kind of one-off tools, mixed capabilities. They don't really consider enterprise, kind of wrapping all those capabilities into one tool. Bottom line is you need something that you can react quickly. Again, the code word was kind of written from the network defender standpoint, and with the frustration of all the forensic wrappers. Basically, the premise is there's some critical data that's really easy to get, that's hard to get in the commercial forensics tools. That would be nice if you just had a tool that did all that for you, collected the information, presented it to you, and allowed you to make some informed decisions about what to do next. So really, the tool focuses on these three areas: disk indicators, memory indicators, and registry indicators. It's sort of kind of like an antivirus thing, but the cool thing is you get to define your own signatures. So I know, at least in incident response efforts that we've participated in, it's been really hard to kind of, with the tools out there, to do these basic things. Like, I want to know, like, what hosts on the network have this file name in hash, or this file name in size? You know, is there a process running that has this XOR key running in memory? You know, I'd like to know that type of stuff. In registry indicators, a lot of viruses and worms and the like can be easily detected just by looking in the registry. So again, the main purpose here is to expose this information quickly for a network defender, and not so much worry about the forensics wrapper. And there's some, you know, sort of some more advanced features we may go into, but really the idea is that this combines a lot of capability that's already out there. So code word isn't like some like awesome new like cutting edge technique or anything. It's really more just combining a lot of features that are out there in open source tools into one tool that uses, you know, encryption, FIPS 142 compliant encryption, XML, things like that, standards, and a server client framework that you can easily deploy and use. Just a little bit more details on the inspiration and why like another tool, right? So just bugs, wasted time on service calls, licensing issues, inconsistent results between versions. I don't know how many people have experienced that, but one version may say you found a rootkit, the other one says, well, maybe not. Misses the simple use cases that you'd like, as a network defender, you'd like to be able to get quickly. And again, we've already discussed most of that stuff. So the goals, again, is to combine all these tools you may have used, or a typical incident responder would use in a response effort. AV scanners, vulnerability analysis tools, enterprise forensics tools, and some rootkit detection like MIR, iSword. These are kind of the broad categories of capabilities for the tool. The signatures detection we talked about earlier, some heuristics, evidence collection, some mitigation options for disabling like features, USB, disabling USB devices, things like that. Other mitigation tasks, cleanup, killing processes, things like that. And then remote analysis, you can connect to the agent and kind of issue some commands and pull some results back. Signatures, again, the heuristics are kind of broken down into 3 levels: user mode, kernel mode, and low-level heuristics. All the low-level heuristics are not implemented, and we'll talk briefly about the other 2. Thorough detection through the signatures and the heuristics. You can receive usable alerts. So presents the information, I think, in a pretty succinct way, and there's detailed logs you can pull from when the tool runs. So I think it's a little more useful than forensics tools. So these are kind of like the application for the tool, right? You can use this as a regular basis, kind of like a compliance thing you may do once a month. Like you run Retina or something to make sure like people haven't installed software they shouldn't be running. Well, as part of that, you could use this tool to kind of, you know, double check those results. A triage tool, which is kind of the point in this talk, code word kind of complements the retry methodology we've talked about from a network defender standpoint, quickly responding to an intrusion. And some root cause analysis, the original infection point. And just as a caveat, you know, it's not forensically sound, it won't solve all your problems, yada, yada, yada. It's a beta tool, don't complain when it crashes, these types of things. So just keep that in mind. 3 components of the tool, 2 are written in C#, and the driver, of course, is written in C. The admin console is what we'll mainly show at the end, and it's just a GUI that basically your responder or your network administrator will drive and deploy agents and collect information. The agent is the actual binary. It's wrapped inside an MSI installer. So I had the painful task of, you know, learning the Windows installer API and the database behind MSIs. So if anybody ever has the chance to do that, like, highly suggest you avoid it. But the agent is embedded in MSI along with other third-party tools. So you can add and remove things in the MSI installer using code word. So if you want to deploy like a third-party, like an antivirus update with code word, you can do that. And also if you have some other tool you wrote, like another driver you want to load or something like that, code word could load it for you. So basically, the quick start, how to use CodeWord, there's 3 steps really. You create an agent from the admin console, you deploy it with an existing deployment mechanism. Right now, CodeWord doesn't have like a, deploy me to this host thing. It relies on some SMS or Altiris, your existing software management system you already have. You deploy it and you connect to the agent, you issue a scan, you analyze the results, you perform any collection or mitigation tasks you want to do. And that's pretty much it. There is one mode that you can deploy the agent in called fire and forget mode, which basically if you have 10,000 machines on your network, you don't want to have to connect to each one individually and scan and pull the results. The fire and forget mode will allow you to just deploy, broadcast the agent out, and it will do all the scanning, the mitigation, collect report and evidence, things like that, wrap it into an encrypted archive, and then send it back to a reporting method of your choice, like a web server or a network share. So this is the admin console view. We'll go into details in each section in a minute. Okay, so step 1, you create an agent. These are the startup modes I mentioned earlier. The second 2, remote control and enterprise mode, are pretty much the same. The only difference is in enterprise mode, it actually will run the scan and then listen for commands. So in remote control mode and enterprise mode, you deploy the agent, it installs as a service, listens on a port, waits for commands from the admin console. In fire and forget mode, you simply deploy the agent, it runs, does the scanning and remediation, reports back to you automatically. And this is kind of the agent settings. If you go back here, you see the agent settings in the tree view on the left. This is kind of what we're going through here, these different tabs for options for configuring the agent. So you can configure the connection, port it listens on, authentication. So right now it basically takes a PFX file, the embedded private and public key, and a password. And CodeWord actually requires that you supply a PFX file for both the admin console and the agent so that they can do the encryption. And there's mutual authentication, and you can issue, you can enforce the certificate issuer for the certificate. And persistence, basically, do you want it to install as a service, or do you want it to run once and remove itself? Stealth, these are kind of like, in theory, things that haven't been implemented, but they're possible. And for the reporting tab, this is the fire and forget mode. So this is only available when you deploy the agent and don't want to connect to it. These are pretty much your options. You have a network share, FTP server, email, web server, those types of things, application level authentication, and that's pretty much it for reporting. So for defining signatures, this is kind of the AV type piece of it, right? So if you want to scan for the existence of a file based on various parameters, scan for the existence of a registry key, those types of things, this is where you would define it. So the one that's selected here is the memory tab. And your action is basically what you want the tool to do once it discovers this, if this signature is matched, what do you want it to do? I think the 2 options are terminate the process or suspend the process. You can define just the process name. So if you want to see like if calc.exe is running or something, you just put the process name in there, and if it is, it will kill it or suspend it. You can also specify keywords, and it will search the process heap space, the process command line, start parameters, and the loaded modules list. So if you know a piece of malware loads a certain DLL that's unorthodox, you could put that here and it would find that. So the other tabs I just mentioned real quickly, the file tab, several parameters, like you can give the file name, MD5 or SHA-1 hash, a PE signature hash, which is a custom like signature I came up with based on attributes of the PE header information. And once you supply those parameters, it will search for all those criteria and show any results. And registry is pretty simple. It's just look for the existence of a registry key, and if it exists, you either remove the key or clear it out. And then registry GUIDs is basically this is based on the idea that malware needs, when it installs as a service, most malware will use a GUID, usually a static GUID, and reuse it across hosts. So normally it will store that GUID value in a registry key somewhere in the registry. So you won't really be able to search for registry indicators without knowing that GUID ahead of time. So you can use expansion variables in the registry GUIDs tab that you can use later in the registry tab to define signatures based on that GUID. So if you want to find a registry indicator that has the GUID in the path, you would first define it in the registry GUID tab and then reference it in the registry tab. Sorry about the little smudge out there, just a last minute change I had to remove, but these are basically the heuristics. I'm not going to go into details of all the different tabs, but for the process tab there, basic cross-view analysis detection for hidden processes. It's pretty standard stuff. So after you've defined your signatures and your heuristics that you want to use in a particular agent, you just click Generate MSI. The admin console will basically embed a copy of the agent binary in the MSI installer along with the configuration parameters you just gave it. Wrap it into an MSI executable that you can launch with SMS, like use MSI exec-s for silent install mode, or -q, forget. And it'll basically install this silently. So once you've defined the agent, assuming we're doing, so right here in step 2, we're assuming enterprise and remote control modes. So this is assuming you want to, you found a host you're interested in, you want to deploy the agent to it, and then connect and kind of pick through the results. So the first step is to, again, specify the PFX file. This is how it will establish this secure communication. I have these checkboxes here to remove a couple certificate checks, just if you want to do this for testing reasons. Like I kind of made this PFX on my own, the keys on my own, so they weren't legitimate and they had certificate chain errors and things like that. So you can disable that if you want. And then you connect to the agent, and this is kind of what the analyst would see. In the left, you have your recent agents. So if you deployed different hosts, it'll remember which IP address is used. Command history in the bottom left. These are just basically like command codes and response codes that the agent received, kind of for debugging purposes. And then some information about what the agent perceived the command was and its response. And the first tab, system info, basically collects all the host information like machine name, IP address, installed network cards, things like that. Information about the agent itself, XML settings, its configuration, stuff like that. This is the toolbar that you would use in a typical response effort. So the big green play button initiates the scan that you've configured heuristics and signatures for. The second button is to update the signature file. So if you just issued a scan, you misspelled a keyword or something in your signature, you can just go back to the other tab, modify the signature, and then generate like an XML file you can send to the agent for automatic updates. The third button is for collecting evidence. So whatever files you found during a scan, you can just checkbox them and download them for further analysis. Mitigate, if again, just clean up what you found and disconnect and uninstall the agent. So you can scan multiple times. Like I said, if you have something you want to add to a signature, you can easily update the signature file and reissue the scan. Here's a quick view of stormworm results. So stormworm's pretty easy to detect. It leaves all kind of footprints on the system. We'll have a demo at the end that just kind of really just shows this in action, just kind of to show you the tool actually exists. So this lists all the registry keys that it found that were a match in the signature. And stormworm drops a driver to disk, and this peers.i now is kind of like a peer-to-peer type list of hosts it connects to. And just to show you real quick the collect and mitigate capabilities, you just basically check the file you want to download, click the third button, the little save icon, and save it to disk. It'll prompt you, this is the mitigate piece, so you can click delete the file, or whatever action you gave it in the signature, this will actually apply that action. And then when it's complete, it'll show the checkbox. So those two examples were based on the enterprise mode and the remote control mode. So this is kind of the fire and forget mode. Basically, it just reports this archive that contains the infection summary report, any mitigation actions it took, and all the evidence that it collected. Again, it's encrypted AES-256, password protected, and it's shipped back over whatever reporting method you specified. Okay, so the first demo, these are going to be real quick, real short demos, just to kind of show you how the tool works. This is the stormworm example. We're going to kind of walk through defining these signatures in real time. The VM guest was infected with stormworm, and we're going to deploy the agent using remote control mode and kind of just examine the registry signatures that we find. Get it to work. Okay, so it's kind of small, so make it bigger. All right, so basically we're selecting remote control mode because we want to connect to the agent remotely. We're going to give it the PFX file, type in the password. These are all the standard options, not really changing much here. For signatures, basically already created a signature template, and we're going to load it here and just show you what's in there. This is the actual signature template file that you can save and load as you create signatures. It's just an XML document. So we imported the signature template. It has these file signatures, these memory signatures, which are keywords. So StormWorm injects a process from kernel mode in services.exe, so that's why we had that signature there. It doesn't actually do it in this case, because there's lots of variants of StormWorm. This one actually doesn't. Right, so we just right-clicked on the MSI installer, installed the agent. Gonna run it real quick from the command console. This would all be automated once you deployed it, but for testing purposes, we're just showing it. Okay, so just verify that the agent is listening. Right port. Okay, so we'll connect to the local host here because we're just scanning the local machine. After we give it, of course, the admin console's credentials. All right, so you collected the system information, just issue the scan. It's using that XML template we imported earlier. If we had something to change, we could go back to that Create New Agent tab, update the signatures, and regenerate the template and send it. Okay, so the scan completed. That's kind of the runtime log down there, command history. So really the only signature here we were focused on was the file signature. So it found these two files on disk. We're going to download them real quick, or just that one actually. And it downloaded to desktop. Okay, so just going to remove the file. Okay, so that's pretty much all we show in this demo. I'm just going to disconnect the agent. So it's just a real basic demo about just showing how to define signatures and then deploy an agent. The next demo is kind of going to show one of the kernel mode heuristics for detecting ERP detection. So TCP ERP is an open source rootkit you can get off rootkit.com. It just hooks the TCP IP stack to point to one of its own functions. So we're assuming we already had the agent deployed locally. We're connecting to it. We already have the heuristic selected, so we're just going to issue the scan. Take a couple seconds. Okay, so basically it reported back that the TCP IP.sys driver was hooked. Its ERP major function code was ERP-mg device control, which is the actual entry in the dispatch function handling table that this particular rootkit hooks. And that's it. So basically, those quick demos just can't go into too much more detail about it right now, but this kind of like suggests at the more advanced features the tool has, and hopefully in the coming weeks, we'll be able to show you guys more and release the tool and all that stuff. So just a couple quick, conclusion slides here to wrap up. Let Mike kind of drive here.
Well, okay, so just some, full disclosure up front, the limitations of our methodology. Like we said up front, you've got some cost up front to prepare for this. whether it be hardware or software. So there is that issue. You got to, essentially talk to your management and spending money on a capability that you may or may not need. So that's always a challenge. And then also, just to state the obvious, or what I would consider the obvious, is all the same challenges that plague regular incident response still, are still inherent in this process. If you don't know your network, which we said was really important, and you don't have any idea where all your hosts are, that's a problem for any response action. And then obviously, how well did you plan and prepare your backups, right? If they aren't available and they didn't work right, this isn't any silver bullet or anything. This all relies on everything else that you do day to day. That all that stuff has to work. So, and then the last piece is, without knowing the whole date and scope of your problem, you got problems. So, final thoughts. Like we've been saying the whole time, preparation is really key for this to be successful. We really think that you can pull off the major features of the methodology, phase 2 and phase 3, in a matter of a few days. I say that because we've essentially done it, so it does work. It takes a lot of time and a lot of effort, but it can be done, and your users, while it's a little different for them, at least they're up and running while you're trying to fight off the bad guy. Going right into that next bullet, obviously keeping your users up and running is the main purpose of this methodology, because it saves your company just gobs and gobs of money. They can continue to be productive, and you can go do your response piece that you're going to be doing. So really, that's really all that we have. This is how you can get in touch with us with any questions. Our website, hopefully, like we said, the tool will be released in the near future. With that, any questions and/or lunch?
Yeah, and/or lunch.
Can you talk a little bit about how you test a recovery plan without actually doing it?
Well, so like for us in our network, the one that I work on, we have a small mirror of our regular network. So you could, say for your SMS scripts or things of that nature, you can test and deploy those in your test and dev network. Obviously, the user notification stuff is not that hard to test out. But yeah, some of the aspects of this you're going to have to do. You're going to have to kind of work it as you go, because it is a lot of work to go forward with this, and it's hard to pull this off in a test scenario. But it does work. We've actually made this work, and yeah. So sure.
What kind of licensing?
Yeah, I don't even plan to license it. I don't. Right. Right. Well, the idea originally for CodeWord was that it would be an open source free tool, and we would release it here at Black Hat. But that's still kind of pending. So as soon as we have updates, like check the website or email us or whatever, and we can give you more details.
Things like security servicing, the whole time, like during your phone app, okay, why don't you do this in everyday life?
Yeah, it's actually a really good idea. It's just really hard to talk anybody into dumping their current infrastructure for thin clients. But yeah, no, I'm working my boss on like a weekly basis at this point to adopt a thin client architecture and just forget having hosts that can be compromised all the time. So yeah, it makes a lot of sense to do this for everyday business as well. Well, in fact, we've already said if we ever have to do this on my network, we're not going back. We'll just continue to operate this way probably.
Two comments. One for your thin client comment. You run with a root-only operating system or read-only operating system, and do this process and migrate to thin clients, and you never have to go back to the root-only ones. Second, for does this only work for one client at a time, or can you deploy it in mass across the organization at every port?
Yeah, for deployment, like that's as scalable as whatever software management mechanism you already have. But for the admin console piece, it's kind of a one-to-one thing. So you have one host you're interested in looking at, the console can connect to one host. But if you use the fire and forget mode, you can deploy it to 10,000 machines, they'll all run the scan asynchronously. They'll collect the information, make the zip file, and they'll all be shipping it back. It's kind of like a push. They'll be pushing the results back to some web server. So you'll have like 10,000 zip files sitting in a web server or a FTP server, and then
A lot of solutions that do that same thing. So how do you propose going through manage the analysis of that files?
right. So that part isn't complete in the tool, but there was a third tab I didn't really talk about it called Enterprise Pull, and that's going to actually mine information out of all those zip files. That's kind of like a beta 2 version.
One of the things that we've been pushing to see is not command-driven push type system. You say push it out and give the stuff back, but actually have pre-installed agents so whoever can install process at the agent there, and then it pulls back on the EPOS.
Right, gotcha.
Or pulls the XML structure and then reports back based on that.
Yeah, a pull capability is already there. It's just not plugged in. But yeah, I get what you're saying, because you don't want to have to like babysit the thing. You want it to kind of report back and run intermittent scans. And the tool already has persistence, like it'll survive reboots, run as a service. So the push capability is just a matter of plugging up a few pieces in it. So yeah, but I get your point.
Do you have any concerns about people using VLAN reversal to go from your network to the one network?
Not until you said that. No, I mean, so.
Background, we use this technique for our work to do disaster recovery type work. We've actually been using it to move entire networks from one place to another, three-stage recovery. And the biggest concerns we have are people traversing from one network to the other, three-stage, I guess, so VMs to make sure that there's good separation. But in a case, we've never used it for oh my God, we're being overrun by viruses type of thing. And it looks like you guys are really targeting things like botnets or other common things that spread themselves. So one question that we've always had, can you use this to defend against somebody who's very persistent? Should we be worried about somebody who's processing one to the other?
So to answer the question, I don't know if this will answer it or not, but the idea is that because you're cutting off access as soon as you figure it out, the idea is that this could be used in a very targeted, very skillful adversary situation. And the reason that we think it could work is that, essentially the tools that they've dropped and that are currently on your network, one, have no communication back at that point, and two, they don't anticipate you doing this, right? So the idea is that, most of the tools that we've seen and we've run across, they have like 8 functionality, pieces, right? They can do X, Y, and Z, but they aren't built to be very agile. So the idea there is they just haven't planned for it. So it's sort of security through obscurity, unfortunately, but it does seem to work so far.
Mike, when you go through this process, you have this downtime, so obviously you could this infrastructure to minimize that downtime, but there is some kind of cycle that they have to go through. They get through the network and then reintegrate your whole network. Now, what's the scalability for multiple vectors at the same time, where if you pull the network off and as you're rebuilding, you get off of something else?
Well, then you got a pretty big problem, right? I mean, yeah. So that's why we're trying to look at different technologies to try to secure the interim stage, right? To try to secure the cluster as much as possible, to try to ensure that most attack vectors these days are file format exploits. Office apps having some sort of binary embedded in them, or an Adobe Acrobat file, or what have you. So we're trying to address the same vulnerabilities that would have potentially gotten you compromised in the first place. But obviously, if you have poor patch management and other issues that are going to allow you to be just re-compromised over and over, I mean, there's really nothing that we can do to stop that, unfortunately.
Well, I'm not saying re-compromise based on poor patching and perform so well as to become an adversary. If you want to get you to become mass compromise, you go through the process, and before you complete this process, another become an adversary option.
Well,
so it's really a question about getting cycles and how do you reduce the cycle such that it's more visible. Get it to eliminating the downtime so you're running through whatever is being thrown at you, even if the real world sense you can attack multiple vectors.
I mean, the reinfection would, I think it would most likely occur like during the response process. So, I mean, you could kind of track it down and see what, it all comes down to root cause, right? Ideally, if the reinfection occurred, it would be in the QNet already. So they would be quarantined in the clean net, a different vector. Right.
Yeah, we don't really have an answer to that one necessarily.
Yeah.
Yeah, I mean, that's essentially what he's saying is that, yes, if you get attacked through some new attack vector that you haven't prepared for in the clean net, then yeah, you're essentially starting all over again.
The point is it would be an agile enough framework that you could do it iteratively like that.
The thing that we've run into in the past is that, unfortunately, during so when I talked about the first two types of methodologies out there, the cut everything offline and rebuild from scratch, or the rebuild online. A lot of times we've seen that people doing the rebuild online method, they don't even get recompromised by something new. They just miss something along the way. And so they end up redoing the rebuild effort multiple times and costing just millions of dollars because they didn't want to take the time to do it right up front. So we're trying to give another solution that sort of fixes that aspect, but it's not, like we said, it's not an easy button. It doesn't fix all the problems out there. But it is another, just another methodology to have in your toolkit. So you could have, you could essentially set up the same situation where, we talked about this for a moment, where when they VPN back in or whatever they're using, that the problem there is they're going to be sitting in possibly their home or their hotel room. They can get into the ASI cluster and do all their work, but I guess the issue is going to be is that they're not cut off, right? So the bad guy can still control their laptop and still do things. And so that's where when we've had a similar situation, we had to do a mass recall of all laptops. It's either recall them or do some sort of remote imaging, which obviously isn't very feasible based on bandwidth and issues. Yeah, that's what we would do locally and then push out a policy possibly that, no split tunneling, things like that, so that at least while they're on the VPN, they're sort of secure. But you've got a compromised host at that point. Yeah.
Well, ideally, during the response phase, you would identify those laptops, but generally a mass recall is probably what would be used.
Yeah, anytime you're relying on the host, you're pretty well in trouble. So,
anything else?
All right. Well, thank you for coming.
Yep. Thanks for coming, guys.